this question is very important. It has come many times in the CBSE board exams. Now this is for indefinite integrals. Same question we are going to do with definite integrals also, with another method also. So I will be trying my best to make this question in a very simplest way. Even you can get this question in your NCERT book in examples also. Okay. So I will be doing whatever possible methods are we can do. Now here we are having, the question is integration of sin x upon integration of cos x plus integration of cos x upon integration of square root of sin x. Okay, square root of all the 4 terms. Now sin x plus cos x upon under the root sin x cos x dx. Now multiplying and dividing by root 2 integration of sin x plus cos x upon 2 sin x cos x. Now here I am just playing a trick. So be careful what I am writing here now. Sorry, it is dx. Now here it becomes under root 2 integration of sin x plus cos x dx upon under the root. Now I am writing here 1 minus 2 sin x cos x. Check it. If we are opening the bracket, 1 minus 1 cancels and we are left with 2 sin x cos x. Now what is the need of this? Just check it. Root 2 integration of sin x plus cos x dx upon under the root 1 minus in the bracket. Now to 1 can we use the identity sin square x plus cos square x minus 2 sin x cos x. That's why I have used it. Okay. So now this becomes root 2 integration of so you should not be confused of all this. Okay. So it will be now root 2 integration of sin x plus cos x 1 dx upon under the root 1 minus in the bracket sin x minus cos x whole square. So I want to make this whole term 1 minus 2 sin x cos x. Even you have gone for the differentiation also. So either I would have written directly also. So I have just shown you. Now it becomes sin x minus cos x whole square. Okay. So now we are having, let sin x minus cos x is equal to t, differentiating with respect to x. We are having sin x becomes cos x and cos x becomes minus sin x. So it becomes plus dx is equal to dt. So numerator sin x plus cos x dx, sin x plus cos x dx is dt. So now question becomes integration of root 2 integration of dt upon square root of 1 minus t square. Is it clear? So now this becomes square root for sin inverse t plus c. Now what was the integration of dt upon under the root square root of 1 minus t square? That was sine inverse t. Now integration of dt upon square root of 1 minus t square is equal to sine inverse t. Plus c. Okay, now it depends on the question. We would have written minus cos inverse x also here. Okay, so now finally we are getting root 2 sine inverse. Now t is sin x minus cos x plus c, and this is the answer. Okay, so a very important question, and be careful to solve this question, and this is the most easiest way to solve it.